Describe briefly the process of transferring the charge between the two plates of a parallel plate capacitor when connected to a battery. Derive an expression for energy stored in a capacitor. This is the simple diagram here. Capacitor and the hole is connected. The electrons are transferred to the positive terminal of the battery from the metallic plate connected to the positive terminal, leaving behind positive charge on it. Similarly, the electron moves on the second plate from negative terminal, hence it gets negatively charged. Process continues till the potential difference between two plates equal the potential of the battery. Let dW be the work done by the battery in increasing the charge of the capacitor from Q to Q plus dQ. Then we can write dW is equal to V dQ, where V is equal to Q by C. Therefore, we can write dW is equal to Q by C times, that is Q times C, Q by C to dQ. Then the total work done in changing up the capacitor is given by, that is W is equal to integration of dW, that is integration with respect to 0 to Q divided by C with respect to dQ. Then we get the value W is equal to Q square by 2C. Hence energy stored W is equal to Q square by 2C, which is equal to 1 upon 2 CV square, which is equal to 1 by 2 Q times V. In second question, a parallel plate capacitor is charged by a battery to a potential difference V. It is disconnected from battery and then connected to another uncharged capacitor of the same capacitance. Calculate the ratio of the energy stored in the combination to the initial energy on the single capacitor. Charge stored on the capacitor, that is Q is equal to CV, when it is connected to the uncharged capacitor of same capacitance. Sharing of charge takes place between the two capacitors till the potential of both the capacitor becomes V by 2. Energy stored on combination, that is U2 is equal to 1 by 2 times C times V by 2 whole square plus 1 by 2 times C into V by 2 whole square, which is equal to CV square divided by 4. Then energy stored on a single capacitor before connecting, that is given by U1, that is 1 by 2 CV square. Then a ratio of energy stored in the combination to that in that single is given by single capacitor, which is given by U2 by U1, which is equal to CV square by 4 divided by CV square by 2. The ratio is equal to 1:2. Derive an expression for the electric field at any point on the equilateral line of an electric dipole. On the equilateral triangle, we see the electric dipole looks like this. The P and Q and minus Q, this is the equilateral triangle where this angle is theta and the charge is plus Q to minus Q and the distance is 2a. Okay. Here at E and E point, there is a plus charge and minus charge Q and the point is P here. Now, the magnitude of the electric fields due to the two charges, that is the plus Q and minus Q, are, that is the E plus Q, we can write it as 1 upon 4 pi epsilon naught times Q divided by R square plus A square, and E of minus Q is equal to 1 upon 4 pi epsilon naught times Q divided by R square plus A square. Then the components normal to the dipole axis cancel away, and the components along the dipole axis add up, we given as, hence the total electric field is given by, that is minus of E plus Q plus of E of minus Q cos of theta P will give the result E is equal to 2QA upon 4 pi epsilon naught times R square plus A square to the power of 3 by 2 times P. This is the expression for the electric field at any point on the equilateral line of an electric dipole. B. Two identical point charges Q each are kept 2 meters apart in A. A third point charge Q of unknown magnitude and sign is placed on the line joining the charges such that the system remains in equilibrium. Find the position and nature of Q here. This is the diagram. Q, two charges, and here the midpoint is Q, and this distance is X, that is 2 minus X. The total distance is 2 meters. If this distance is X and the remaining distance, this is 2 minus X meters. Then, system is in equilibrium. Therefore, net force on each charge of system will be 0. That is, for the total force on Q to be 0, then we can write 1 upon 4 pi epsilon naught into Q divided by X square is equal to 1 upon 4 pi epsilon naught Q divided by 2 minus X whole square. Then X is equal to 2 minus X, and 2X is equal to 2. Then X is equal to 1 meter.